In this video, we're going to understand about differentiation. But before giving a precise definition of differentiation, I want to give an intuitive idea of derivatives. Back in 16th century, Galileo did an experiment with that of a body. He dropped it from a tall cliff and he observed that a distance covered is equal to 4.9 t square meters in t seconds. That is, if we talk about the distance, it's a function of time, given by the equation s or t equal to 4.9 t square. Here to the right side, you can see I had made a table for time and distance, where time is in seconds, distance in meters. For different time, we have a different distance covered. Here, this is the graph for time axis and distance axis. In the 17th century, Newton was pondering about the following bodies. For this example, we're gonna take example of mythical apple fall. He knew that if an object is dropped with an initial velocity equal to 0, once it hits the ground, its velocity will increase. He knew about the Galileo formula for distance, but he was interested in finding the velocity at a specific time. For example, here we can take time equal to 2 seconds, and he was interested in finding v2. For this, one way to approach the problem is to find average velocity for various intervals of time ending at 2 seconds and hope that these throw some light on the velocity at 2 seconds. That means here we have a time equal to 2 seconds. We are gonna find average near about it, and it can give us some idea about the velocity at particular instant. We can say if we wanted to find velocity equal to 2 seconds, for a common man we can say he wanted to find instantaneous velocity. Velocity at one point. But for this, we had to find average velocity. This can throw some light about a time equal to 2 seconds. We know that average velocity is equal to distance traveled by time elapsed. Now we had to find average velocity for different intervals for time ending at t equal to 2 seconds. I have pasted the table above table. Now we had to concentrate on time equal to 2 seconds. That is this time. And with respect to it, we will find average velocity for time near it. If I talk about average velocity, that is for a time equal to 2 seconds. Okay, first we will take with respect to 0. And the displacement or distance along with it is 0 and 19.6. Average velocity is distance traveled, that is 19.6 minus 0 whole divided by time elapsed is 2 seconds minus 0. If we simplify it, it will be 9.8 meter per second. Now for the interval 2 seconds, and 1 second. Average velocity will be distance traveled, that is change in distance, which is 19.6 minus 4.9. 19.6 minus 4.9 whole divided by, that is time elapsed, change in time, 2 minus 1. If we solve it, it will be equal to 14.7 meter per second. Again, if we find average velocity for interval 2 and 1.5 seconds, the distance traveled along with it will be 11.025 and 19.6. For this, average velocity will be equal to change in distance, that is 19.6 minus 11.025 divided by the time interval for it, or time elapsed, that is 2 minus 1.5. If we simplify it, it will be 17.515 meter per second. So with this, you can take different intervals of time. For example, the next one will be between 2 and 1.8, and the distance covered for this interval is 19.6 minus 15.876. Then again, we can take for intervals 2 and 1.9, and distance traveled for this is 19.6 minus 17.8689. And then lastly, 2 for interval 2 and 1.95. The distance traveled will be 19.6 minus 18.63225. Here I have given a table for average velocity. If you are going to, take the interval 2 and 0, take interval 2 and 1, take interval 2 and 1.5, take different intervals. Have you observed anything when we come closer to the time interval ending at t equal 2 seconds? Yes, we have observed the average velocity is gradually increasing as the time interval ending at t is smaller and smaller. So with this, we will get a better idea of velocity at time equal to 2 seconds. Or we can say that average velocity is almost approx or just above 19.55 meter per second. The reason it is above 19.551 meter per second, here, for example, you have taken 1.99 and time interval 1.99 and 2. You can take 1.9999. When you take smaller and smaller time interval, you get a better idea about the average velocity at time ending equal to 2 seconds. Now again, if I will copy paste this and I will paste it here. So here we have taken time interval in increasing order in the first table. Now here we will take time interval in decreasing order. We'll focus on time equal to 2 seconds. Okay. Now, first, we will take for time interval 2 and 4 seconds. The distance traveled for this interval is this. Computing average velocity, we have distance traveled by time elapsed. Distance traveled is change in distance. That is 78.4 minus 19.6 divided by 4 minus 2. If we compute it, it will be 29.4 meter per second. Okay, we're approaching to 2 from bottom side. Now again, what if now instead of 4 we will take interval 2 and 3 seconds, and the distance or displacement along with it is 44.1 and 19.6. Computing average velocity, it will be equal to change in distance, that is our 44.1 minus 19.6 all divided by change in time interval or time elapse, 3 minus 2. If I simplify it, it is 24.5 meter per second. Now we are coming closer to 2. Okay, if I take 2 and 2.5, here it will be 19.6 and 30.625. For this, average velocity will be change in distance, that is 30.625 minus 19.6, and change in time is 2.5 minus 2. On simplifying it, it will be 22.05 meter per second. When we are coming closer and closer to the time interval 2, you can see here the average velocity is decreasing. For example, for last part, if we take value of 2 and 2.5 interval, the distance or displacement along with it is 19.6 and 20.52925. That is change in distance or displacement, 59225 minus 19.6 divided by change in time interval or time elapse, change in time, 0.5 minus 2. If we compute it, it will be equal to 19.845. Now what, instead of taking the time interval 2.05 and 2 seconds, that is this, we will come more close to that of time interval 2 seconds. That means this time we will take interval 2.01 and 2 seconds. For this, if you compute average velocity, that will be equal to 19.649 meter per second. Here we can observe that when you are decreasing the time interval, okay, the average velocity will decrease. That means, based on this, we can conclude that our we can say that average velocity is more than 19.649 meter per second. And based on this, we can calculate that, we can conclude that velocity of the body at t equal to 2 seconds is roughly between 19.551 meter per second and that of 19.649 meter per second. Or technically, we can say instantaneous velocity of time equal to 2 seconds is between these two values. And it's well known that velocity is a rate of change of displacement. So, what we have accomplished in the following, that is from the given data of position time, or we can say distance time, we have estimated the rate of change of distance at a given instant of time. How we have done this? When we come closer and closer to that of a time interval t equal to 2 seconds, we got a better idea about the velocity. Okay, that means when we're coming closer to that of a time interval equal to 2 seconds, the average velocity approaches equal to instantaneous velocity. We can say that derivative of the distance function s of t equal to 4.9 t square at time equal to 2 seconds is between 19.551 meter per second and 19.649 meter per second. I want to add one more thing to this. Whenever I'm using distance and displacement, I'm interchanging in this video two words. The reason is for a straight line here from the experiment, the ball was thrown from the top to the bottom. It was covering a straight line, and for a straight line, distance and displacement are just same things. The idea of, if I will give a brief idea of derivatives, it relies on the thing that how the output changes whenever there is a slight nudge in the input. Okay, here whenever we were decreasing the time interval, okay, there was a gradual change in the average velocity. This is what is all about the derivatives. How the small change in input results in the change in output. This is the idea of derivative. I'll be talking more about this in the next video.